Launch Director.
Launch vehicle is ready for launch.
We have ignition.
You have permission to
2,
launch.
1, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute, and we have an indication of spacecraft separation.
Good morning. I'm Pam Ziert, a mechanical engineer at ULA, and your host for today's live coverage of the Atlas V Silent Barker NROL-107 launch. I'm joining you from ULA's Advanced Spaceflight Operations Center at Cape Canaveral Space Force Station in Florida. Liftoff is scheduled for 8:47 a.m. Eastern. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. The count is currently in a 30-minute planned hold. We have 2 planned holds in our 7.5-hour launch count, which give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues, and we're proceeding towards an on-time liftoff. At the request of our customer, we'll end today's live coverage following payload fairing jettison. Before we continue, let's check in on today's weather. The Space Launch Delta 45 forecast for this morning's launch is looking good. Let's take a look at the numbers. The probability of violating launch constraints is 5%. Ground winds are 4 to 8 knots out of the south, and the temperature is 81 degrees Fahrenheit. The primary concern for launch is the cumulus cloud rule. Today's launch is a joint National Reconnaissance Office and U.S. Space Force mission to improve space domain awareness. This mission meets Department of Defense and intelligence community space protection needs by providing the capability to search, detect, and track objects from a space-based sensor for timely custody and event detection. Silent Barker NROL-107 will strengthen the NRO's ability to provide a wide range of timely intelligence information to national decision-makers, warfighters, and intelligence analysts to protect the nation's vital interests and support humanitarian efforts worldwide. ULA is using an Atlas V 551 rocket to launch Silent Barker. Built in ULA's production facilities in Decatur, Alabama, and Harlingen, Texas, this is the 98th Atlas V launch and ULA's 157th mission. Let's learn more about this rocket, which has been used to launch so many critical payloads to space.
The Atlas V rocket, once fully stacked, stands 196 feet and weighs nearly 1.8 million pounds fully fueled. At the base is the Atlas V Common Core booster, powered by an NPO Energomesh RD-180 engine. For additional thrust at liftoff, 5 Northrop Grumman solid rocket boosters, or SRBs, are attached to the rocket. Atop the booster is the ULA Centaur second stage, powered by an Aerojet Rocketdyne RL-10 C11 engine. Spacecraft are encapsulated inside a protective 5-meter diameter payload fairing, produced by Beyond Gravity in Decatur, Alabama. With production complete, the rocket travels from Alabama to Cape Canaveral on ULA's rocket ship. Once in Florida, a series of events lead to today's countdown. The process begins by lifting the 107-foot booster onto the Mobile Launch Platform, or MLP. Next, we mate the SRBs. Then the Centaur second stage is transported to the pad and lifted into position. Lastly, the encapsulated payload fairing is lifted and mated to the Atlas V rocket. Once fully assembled, the launch countdown begins by moving the rocket from the Vertical Integration Facility, or VIF, to the pad. To complete this move, which spans about 1/3 of a mile, the rocket is transported by the MLP. Weighing in at approximately 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities lines. Throughout the 20-minute trip, rail cars lead the move, with the payload van providing spacecraft communication and the ground van providing support for the rocket. At the rear of the convoy is an environmental control system, which provides air conditioning to the payload and the rocket. Trackmobiles power the nearly 3 million pound convoy. With the rocket on the pad, the launch team then transitions to fueling and other final preparations.
ULA's Atlas V will head southeast from Space Launch Complex 41. Here's a look at today's ascent.
generating a combined liftoff thrust of more than 2 million pounds. The RD-180 engine and 5 solid rocket boosters ignite to start ULA's Atlas V rocket on its trip to geosynchronous orbit. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path with an easterly heading while minimizing the dynamic pressure the rocket experiences during flight. Within the first minute of flight, Atlas V reaches Mach 1, the speed of sound. Within the next 2 minutes of first stage flight, the Atlas V rocket will quadruple its velocity, following jettison of the 5 GEM 63 solid rocket boosters. The multi-satellite Silent Barker mission is encapsulated inside a 5-meter diameter payload fairing, which is a sandwich composite structure made with a vented aluminum honeycomb core and graphite epoxy face sheets. Once the rocket has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned, and the mission continues to its final destination, where it will improve space situational awareness.
In addition to logos representing ULA and the U.S. Space Force, along with the American flag, on today's Atlas V we see mission artwork provided by the NRO.
The artwork on the payload fairing features a fox, representing the cunning of the intelligence community and the Department of Defense that gives our warfighters the edge against America's adversaries. Above the fox, we see the moon and stars, showing the commitment to always being on guard to protect American interests and freedom. The moon is waxing crescent, symbolizing that the work is not done and there is still work ahead. The rocket also includes dedications to teammates who are no longer with us. Let's remember our ULA teammates. Willie Miller served as the Titan Centaur chief engineer for many years, and in 2003, following the final Titan flight, became the Atlas chief engineer. Willie's technical leadership significantly contributed to the Atlas V program's success. Willie was responsible for airborne and ground hardware performance, software technical performance, mission-unique design, analysis, and performance margins. He was responsible for the evolutionary improvements to the Atlas product line and provided technical leadership for all anomaly investigations and troubleshooting to ensure consistent engineering processes and standards were applied. Willie exemplified and promoted ethical behavior and personal integrity. He is greatly missed. Estill Morgan joined the then McDonnell Douglas Delta II program in 1989 at the Cape's Space Launch Complex 17 as a certified welder and fabricator. He supported quick response projects in the flight hardware building, including ordnance installation, and supported many pad modifications to accommodate the Delta III program. In 2003, Estill joined the Delta IV team in the machine shop, supporting fabrication of ground support equipment. As the lead technician, he improved the technology it employed, enhancing capability and capacity, while leading 12 machinists, welders, and fabricators, and enjoying every day doing what he loved. Estill was a loving father, husband, son, and friend, as well as a respected and accomplished softball coach within the community. He will be missed for years to come.
With this launch, we are also remembering an NRO teammate. Here is Mission Director, Colonel Eric Zarybaniski.
Attention on countdown 1. This is the MD. This morning's NROL-107 launch is dedicated to the memory of Captain Albert Al Perez, United States Navy. Captain Perez dedicated countless hours of deep technical expertise, ensuring the success of multiple National Reconnaissance Office missions. His warm personality, team spirit, and phenomenal leadership will be remembered by the intelligence community and the United States Navy. To our fellow patriot, fair winds and following seas, may you rest in peace. MD out.
ULA is proud to have launched nearly 100 missions in support of national security. Let's hear more about ULA's commitment to defending our nation.
Before I joined United Launch Alliance, I was in the Air Force for 28 years. The majority of that time was in the rocket business. My last assignment was the director of the Office of Space Launch at the National Reconnaissance Office. So this mission today means a lot to me. The importance of the satellites that ULA puts up for this nation cannot be overstated. It provides the eyes and ears, the communications links, the navigation that enables our men and women to come home safely. Therefore, a launch provider has to be 100% reliable. And that has to be a culture. It's not just a day of launch philosophy or how you handle an anomaly. You know from the moment you walk in the door of your first day what the most important thing is. And ULA is not satisfied until our customer has had a successful spacecraft separation. ULA has a rich heritage of supporting national security space launch. We have had 97 successful launches supporting the defense community. We look forward to taking the best of Atlas and Delta, combining them in the processes, procedures, and hardware on the Vulcan vehicle to continue to support the national security space community going into the future. From processes like vertical integration on the ground to complex missions from LEO all the way to GEO. ULA is not afraid to take on the hard missions because that's what our nation depends on us to do. ULA is proud to be the launch provider for vital national security missions.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the count. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling.
Minus 7 minutes.
Status check to proceed with terminal count. Atlas systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2.
Go.
Gas. Go. Electrical systems. Airborne.
Go.
Ground. Go. Facility. Go. RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM. Go. Umbilicals.
Go.
ECS.
Go.
Redline monitor. Go. Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1247 Zulu.
Verified.
Polling is complete. The ULA launch team and the Space Force mission director are go for launch. From T-minus 4 minutes until launch, you will be listening to Dylan Rice and his team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the booster and Centaur and arming the flight termination system. At T-minus 25 seconds, you'll hear Go Atlas, Go Centaur, Go Silent Barker, NROL-107. This is the final status check of rocket and payload readiness. At T-minus 3 seconds, the main engine ignites, followed by ignition of the solid rocket boosters. Then, after seeing Atlas V lift off the launch pad, you'll be hearing flight commentator Rob Gannon providing launch vehicle ascent data.
L minus 4 minutes, 30 seconds.
This SCTD on channel 1, the SVLS is configured for launch.
Roger. All steps complete prior to terminal count.
This is Atlas Mission Control at T minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark. 2:55.
The countdown clock has resumed and we are go for launch at 8:47 a.m. Eastern. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps taking place.
.330.
Atlas hydraulics at flight pressure.
T minus 3 minutes.
Pressurizing Atlas tank.
Securing LO2 topping.
2:50.
FTS internal.
.159.
Vehicle
155.
internal.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch
137.
enabled.
T minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
OCU's armed.
SCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valve lock.
T minus 1 minute.
T minus 1 minute.
Range green.
.40 seconds.
Stable at step 3.
Verify ECS reduced for launch.
25 seconds.
Status check.
Go Atlas. Go Centaur.
Go Silent Barker, NROL-107.
T minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying Silent Barker NROL-107 for the National Reconnaissance Office and the United States Space Force.
SRB chamber pressures continue to climb out. We have entered our first throttle bucket for the RD-180. Everything is looking good. Coming up on 30 seconds into the mission. PU has gone to closed loop control. And we've completed pitch program. Mach 1. Vehicle is now supersonic. Coming up on max Q. Max dynamic pressure. And we're throttling up on the RD-180s, still seeing a normal burn profile on the SRBs. Approximately 10 seconds, we'll be throttling down for SRB burnout. Body rates look good, acceleration looks good. Throttling down in preparation for SRB burnout.
You are hearing the voice of Rob Gannon providing launch vehicle ascent data.
SRBs are rolling off. And we have burnout. All 5 SRBs are rolling off, approaching 0. RD-180 continues to operate normally. About 10 seconds to jettison. RD-180 continues to operate normally. And we have jettisoned all 5 SRBs. And the vehicle's now in closed loop guidance, as expected. RD-180 continues to operate normally, executing the throttle profile as expected. There are 2 minutes to nominal BECO. Next event we're looking for is throttling down to 2.5 G constant acceleration in preparation for fairing separation. We fired the pyro valves, activating the reaction control system on the second stage. Coming up on fairing jettison. Fairing jet. And CLFR separation is completed as well. Throttling back up.
This is Atlas Mission Control at T plus 3.5 minutes. We just heard flight commentator Rob Gannon confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally. At this time, we'll end our live coverage. For more information on the Atlas V vehicle, visit ulalaunch.com. I'm Pam Ziert. Thank you for joining me this morning. Before we sign off, let's take another look at liftoff of the Atlas V rocket with Silent Barker. T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying Silent Barker NROL-107 for the National Reconnaissance Office and the United States Space Force.
SRB chamber pressures continue to climb out. We have entered our first throttle bucket for the RD-180. Everything is looking good. Coming up on 30 seconds into the mission. PU has gone to closed loop control.